Okay, so next thing we have is Archaea. So we're talking about this now, Archaea. So it's probably going to be another flowchart. They are called extremophiles. Phile means loving. Extreme means they love extreme environments. So since this was first discovered in extreme habitats, they thought that it's more close to the environment that was found on early Earth, so they came around first. And again, that's where the name come from, Archaea. So they're extremophiles. They like really hot temperatures. They like salty environments. They like sulfur, carbon dioxide environments. So Archaea, they live in places that lack oxygen. So like the swamp, they are or in the environments that are extremely hot in volcanoes, salty, like high salt content, or acidic. There are some that live in moderate environments. So not all of them are extremophiles. Some of them might be living in moderate environments, means not very high temperature, just a normal temperature, not too much salt either. So they are very important for recycling. So they're very important for geochemical cycles on land. So they're starting to organize into phyla. So they're still kind of working on it. So they're very important for recycling on early Earth. They were the ones that basically recycled a lot of things. If it wasn't able to recycle, then there'd be a lot of, I guess, pollution around. This reminds me the salt flats. So if you go over Albezo, you look down from your aeroplane, you're going to see all these different colors. These different colors are coming from Archaea species living in there. So what's happening here is they're trying to dry out water and create salt. So they fill these ponds with water from San Francisco Bay, and then water evaporates, and then the salt is left. So that salty environment, that's where some of the Archaea species live, and that's where all these colors are coming from. So that's one example. Have you guys seen this? Salt ponds? No? Okay. Another one you remember is Yellowstone hot springs. So in this Yellowstone hot springs, there's really hot water, boiling water. And these colors, they're not coming from the rocks. They're coming from the Archaea species. They like living in hot waters. That's where these colors are coming from. So I really recommend you guys go to Yellowstone and look at this. Don't worry about the super volcano. Doesn't matter where you are. If if it erupts, it's going to kill you. So these colors are coming from Archaea species that live in extreme environments. So not all the bacteria are harmful. There is bacteria that's doing a lot of good stuff. One example is nitrogen fixation. This is a peanut plant. So prokaryotes in the root nodules of this peanut plant, they do nitrogen fixation. That is taking the nitrogen in the environment and converting it to ammonia. And that's one of the materials that's found in the fertilizers. If this is happening naturally, maybe you don't even need a fertilizer there. So this is very important. Like I said, that nitrogen is locked in and it has to be converted into another form to be useful. And some of the bacteria is doing that. And it's very important. That's a very essential role. So if maybe this bacteria wasn't around, there would be no nitrogen fixation, and I don't know if the life would be around. So that's one thing that's beneficial for. And then only few species of bacteria and archaea can use nitrogen. Without nitrogen fixation, most nitrogen would be locked in the environment. So that's what I just said. It would be locked in if it wasn't for these archaea and bacteria species that can actually use that locked in nitrogen and convert it maybe to another form. Okay, so I've been saying that not all the bacteria is harmful. There is some beneficial bacteria. There is some neutral or harmless bacteria that's living. If we're talking about our body, there is bacteria living on your skin. There's bacteria living in your mouth, in your gut, in your reproductive system. So there's bacteria almost everywhere, except maybe in your bloodstream or in your body cavities, maybe where your bone marrow is. So maybe there's no bacteria there, but there's bacteria almost everywhere. And because there's so much bacteria, you're not getting sick all the time. So it's living in a mutualistic relationship with your body. So it's harmless. So harmless bacteria can help crowd out pathogenic bacteria. So that's when I was saying if you keep using hand sanitizer and it kills all the harmless bacteria that's there, it's going to open up space for the harmful bacteria. So bacteria is not going to cause infection unless it's in a space where it's not supposed to be. So if it stays in your gut, it's not going to cause infection. uh, so in your appendix there is poop there, there's bacteria there. So it's not going to cause an infection if it's just there, but if that appendix bursts, it gets in your bloodstream, then you have infection. So if it gets in a space where it's not supposed to be, it's going to cause infection. There's lots of bacteria that's helping us um, basically crowd out pathogenic bacteria. So if you're taking antibiotics for an infection and you know sometimes those antibiotics cause some gastrointestinal problems and it kills the bacteria that's in your gut, then you can start eating, you know, maybe yogurt or some of these fermented tea, maybe that kombucha I think they sell it at Costco. So I don't know if you guys heard about that. So you can take those things where you would kind of help your body get that helpful bacteria back or that mutualistic bacteria back so you don't get sick from other bacteria. So not all of the bacteria is causing you to get sick. So harmful bacteria that cause disease, you can either, you know, eat it in your food if you don't properly cook it, especially like that salmonella. If you don't really wash the egg and you start to drink raw eggs and you don't notice there are some eggshells in your drink, then it's gonna cause you to get sick. So it can be ingested or inhaled, or they can enter your body through wounds, or orifices are the openings like your mouth. Um, so if you maybe go to cow place where there is maybe they're preparing meat, but they're not very careful about sanitization, then some of that E. coli from the intestines of cows can get onto that meat. And if you don't properly cook it, it can get you sick. So undercooked hamburger meat, you know, because if there is E. coli on there, you eat it, then it's going to cause infection. Um, So we take antibiotics. Some of the microbes die. I think I already told you this. If you're taking antibiotics, some of them die, and that leads to secondary infection. We get upset stomach, get diarrhea. Some of them cause diarrhea because they're killing the bacteria that's living in your gut. Then you have to kind of recrowd that place with maybe, you know, some yogurt or some of those good bacteria. I think I've told you this before. um can't remember the exact name of the infection, but that's when so there is some good bacteria that's found in your poop, and if to recover from that infection, they give you poop and it has to go down through your throat, so just to recrowd that area. So they try to recrowd the area if it's, you know, deadly infection or something like that. But yes, taking antibiotics can lead to secondary infections. So some of the beneficial or benefits of these archaea and bacteria species are, you know, use it to make cheese, to make sourdough bread, some of the bacteria. So I know people use yeast, but they also use bacteria for some of the sourdough bread. Also, some of the bacteria, it can help break down toxic waste material. If there was no bacteria to do that, then it wouldn't be good. So that's very essential. Some of the bacteria is even used to make insulin. So I think I talked about this before, but you can use plasmids. You can use plasmids to make insulin, and that's that needs to be injected in some of the people if they have certain type of condition. So they can use bacteria to make some of the medicines like insulin. Another thing is, if it wasn't for bacteria, it wouldn't be getting decomposed. Some of the stuff wouldn't be getting decomposed. So if a tree falls down, logs broken down, bacteria is something that's going to compost the dead tree. If there was no bacteria, then the dead tree is going to stay around until a fire comes through. In Carboniferous period, when there were a lot of dead trees, there was no bacteria to decompose it. Then the fire came around and basically it burned all those trees, and that's where the coal and petroleum that we use today is coming from. So bacteria, they also decompose the trees. So that's prokaryotes.